Today we can see the applications of adsorption. We discussed some of the applications during the classes that we have taken already. For the examinations, you can expect questions from this part. So you have to study 3 or 4 applications. So the first one is production of high vacuum. How will you make a vacuum? By removing air from a particular area. When we use some methods to remove the air, there will be some traces of air remaining in it. To remove the remaining traces of air, we can use charcoal, which can adsorb the air from the container or that area. So production of high vacuum. The second one is in gas masks. Gas mask, that is a device which consists of activated charcoal or some other adsorbents. So the foul smelling gases or poisonous gases will be adsorbed by the charcoal. Another important application of adsorption, removal of moisture or control of humidity. Silica and aluminum gels are used as adsorbents for removing moisture and controlling humidity. Aluminum gel is not familiar to us, but silica gel, use of silica gel, that is very familiar to us. Silica gel adsorb moisture. Thus, it is possible to control humidity. Another important application, removal of coloring matter from solutions. We discussed it as one of the examples for adsorption in the first part. Animal charcoal can adsorb colored solutes from solutions. The removal of color of sugarcane juice already we discussed. Another example, heterogeneous catalysis. That is our next topic. There we will study it in detail. In heterogeneous catalysis, catalysts adsorb the reactants on its surface. So there the process is adsorption. Another application, separation of inert gases. Separation of inert gases by adsorption. You can see the figure, just a figure to show the separation of inert gases by adsorption. Helium and neon are adsorbed here. Krypton and xenon are adsorbed here. Argon is adsorbed here. So gases are passing from this side. You can see it. So in that way, inert gases are separated. Another important application in medicines. Some of the medicines kill germs by getting adsorbed on them. Medicines will be adsorbed on the germs, and that medicines can kill that germs. That is by adsorption. Here in this figure, you can see an example. Adsorption of medicine on the germ. Details, we don't want it in details. It's just to understand. This figure is shown in order to understand the adsorption of medicine on germs. Next, froth floatation. What is froth flotation? That is a method for the purification of ore. Method for the purification of ore. What is ore? That is a mineral which is used to extract metals commercially. That is an ore. So for the purification of ore, we can use froth flotation. In froth flotation method, the ore particles are adsorbed by the froth. So adsorption is used there. Another example, adsorption indicators. An example is eosin. Eosin is an adsorption indicator. So it is another application. Another one is chromatographic analysis. Last year we have studied chromatographic analysis. In column chromatography, there is an adsorption column in order to adsorb the components of a mixture. So these are the important applications of adsorption. Now some questions, we can see some questions. Write in 2 characteristics of chemisorption. We discussed 8 or 9. So you can write it easily. From the name itself you can write chemisorption is due to chemical bond, unilayer adsorption, activation energy is needed, high enthalpy of adsorption, a number of points are there. Why does desorption decreases with increase of temperature? We know with increase in temperature desorption starts, and for desorption no activation energy is required. So if you increase the temperature, the weak van der Waals forces of attraction will be overcome by the adsorbates, and that will be desorbed. Why are powdered substances more effective adsorbents than their crystalline forms? The reason adsorption increases with the increase in surface area. So all of you have to write its notes and write the answers to the questions.